So in the view menu, upper portion, undo view change, that's simply if you spin the model or change the view in some way, undo view change just goes to the previous one. If you select pan, rotate, or zoom, you can use the left-hand mouse button to perform that operation. For pan and rotate, it's usually quicker and easier just to use the center mouse button when you're in the modeling screen, which by default, the center button will rotate. If we use the center button, we just rotate the model around. And if we hold the shift key down, it allows us to pan back and forth. The set view command is a command available where you want to type in a specific viewing angle. And as I mentioned earlier, when you spin around, it's essentially running the set view command, and you're graphically selecting a heel, pitch, and yaw angle. And as I said, I'll hit Control C here to copy that echoed command here. And if I were to spin the model around, we can come back into the command window here. And if I hit Control V to paste that back in and hit return, it goes back to that original view. When you do set view, it's essentially echoing the command set view angles. And then here it's asking for, say, 30 and we can close the brace if we want, but I think it'll do it automatically if you don't. And it goes to that angle. Now, it didn't echo the rest of it in there, but that's essentially what the set view command does. Set view style has options for some of those other features that we just talked about: black and white background, turning on and off the nodes, shrink and unshrink the elements in solid or wireframe. Set visibility allows you to turn modules on and off in terms of their visibility. And if we want to, say, just view the bow, we can set the view part to be this substructure, but we can turn off visibility of specific modules within it. We can turn that visibility back on and just make it transparent if we want. And actually, if we make a couple of these modules transparent, you can select up at the substructure level, say turn transparency off, and it applies that to all the modules underneath that substructure. Set window simply turns on and off these three tabs. So in terms of the display of the model within Maestro, when we view by element type, and this is the default view for Maestro, it tells us a lot about how the model was built. Each of the elements is color-coded. So as we talked about strakes earlier, the strake runs from one end of the module to the other, and the strake has multiple components. This dark blue indicates that it is a strake element, and that dark blue quad is a strake panel. The transverse frames on a strake are displayed in red, and in yellow is a strake girder. Now, the strake girder only appears at the starting edge of the strake. So if these strakes were defined using this endpoint as the first one and this endpoint as the second, and then the next strake had this endpoint as the first and this endpoint at the second, you would only be able to put a girder on this endpoint because it's the first one on each of those strakes. So this model was most likely defined with the strakes. This strake was defined as, first edge, second edge. The next strake was first edge, second edge, and so forth, working up the side shell. That way you could have a girder at each one of those edges. A standard quad element is displayed in light blue, and a standard tri element is shown in light green. You may also see them listed or referred to as additional quads or additional tris to distinguish them from a strake. A rod element will be displayed in brown, and a standard beam element, an additional beam element, is shown in orange. Now in green here, you see a compound element, and a compound element can consist of a quad, a tri, a beam, or a rod. It's a collection of elements, but a compound is used to create repetitive structure along the length of a module. And compounds have to be defined using endpoint nodes, essentially those endpoints that run the length of the module and have all of the nodes for the divisions along the length of the module. The endpoints which are used to define strakes, can also be used to define these compounds. And then when you edit the compound, you can say how frequently it repeats along the length. You can have it only at, say, the first node point on, or the first division of the endpoint. I think they're referred to as sections in the dialog to create the module. So it would be the first endpoint section or whatever. And you can have it at, say, the first, third, sixth, and so forth to repeat that structure along the length. If it's not a parallel mid-body, let's say it's near the bow and it starts tapering down, well, each of those elements will start getting smaller and smaller as the structure tapers in. But because they're all tied to those endpoints, it's basically just connecting all of the same endpoints on the first location, the third location, the sixth location, and so forth. So I guess next under the view menu, we have wettable elements. And once you're done building the model, before you do the hydrostatic balance and everything and check, and well, I guess you'd need to define your loading condition first and load the model before you want to do the hydrostatic balance. But at some point after you've completed the model and before you do any of the analysis, you'll want to check what are the wettable elements. And these are the elements that will accept hydrostatic pressure. So you can simply turn on the wettable elements. And by default, when you create them, I don't think any of them are wettable, or if you import a PLY file, they are not wettable by default, but it's very easy to select a group of elements and toggle the wettable property so that they will accept hydrostatic pressure. Now, if you edit the model, sometimes like you split an element in two because you made some modifications and now you need to add some definition in here, say add an extra beam or something, and you need to split some of these elements. When you do that edit, normally the properties such as whether or not it's wettable or whether it's on a tank boundary will propagate to the two children that are created when you split it. But if you were to delete it and recreate it, it wouldn't be wettable because it would be a new element. You would have to make it wettable. But the ability to view just the wettable elements makes it easy to find where there may be some missing or some extras that are internal to the hull that shouldn't actually be wet. When you view by ID, essentially each property has an ID number. And in this case, I think we're looking at the plate properties here. And the first one is typically the null plate property. Well, it'll generate errors if there are some null plate because it's not a defined material. But when you create your additional properties, as you assign them to the model, they'll be listed as property 2, 3, 4, 5, and so forth. To find out what those actually are, you can use the dynamic query and just hover over one of them, see what that plate material is, the thickness and the type of material. Oh, and actually this is also an important feature here, is when you're viewing by ID and you're using the dynamic query, you can change what that property is. So if we turn this off and we view this model by plate property and we do a dynamic query, we can see that's half-inch plate, that's quarter-inch plate, and this is ST24. It's the default steel property in here. But if you right-click, it allows you to change that. It shows all of the currently defined plate options, and I can simply change that to half-inch plate if I want. Now, because it was part of a strake, it changes the whole strake. You can't change just one strake quad. You have to change all of them. But if you did want to change just one, originally, as we recall, this last one got converted to an additional quad and an additional tri because it had to tie into a different spacing at the end here. If I were to change that one, it would only change the one element because it's not part of a strake. And we can see what exactly each element is if we switch back to the element type view. For viewing restraints, you can change the view to show the restraints in the model. And when you do this, the rest of the model will be converted to a wireframe display, and you'll see various restraints displayed in magenta. And it'll show which axis is restrained for each of the nodes that has a restraint on it. In this particular case, at the bow, we're restrained in vertically, transversely, and longitudinally. And at the stern, there's one restraint for vertical and transverse. I guess depending on the analysis, a lot of times now the restraints aren't actually needed. If you have a balanced model, if there are no accelerations, or actually, even if there are for the hydrodynamic loading, I don't think you need to apply additional restraints. It automatically balances the model, and it just creates a soft spring to prevent any unbalanced forces like sideward drift in a hydrostatically balanced model, or yaw, where there's no opposing hydrostatic restoring force. But if the model is restrained, this is how you would view the restraint locations and directions. The edge display is very important by default. The most useful one there is to display free edges. And this is one of the standard checks that you'll run through at the end of the model. When you tell it to display free edges, it does it in two stages. First, it displays all free edges, and they're shown in red. And some of these free edges you'd expect. When you run a free edge check, it'll run through the model, find all of the free edges in the model, and then ask a question whether or not you want to check those free edges for modeling errors, which when you're getting ready to run, you certainly will want it to do that. And what it'll do is go through all of those free edges and eliminate any of these expected free edges, at the perimeter of the model, the top of the bulwark, opening for a doorway, various places where you would expect a free edge in the model. But if, say, you see a free edge across the deck here that's spanning two of those strakes, there's a good chance there might be a beam underneath it or a quad on a bulkhead that spans two of the strakes rather than one. So you don't have edge-to-edge connectivity there. If you had a single beam that ran across both of these, it would display as a red line there, and it would be something to investigate. That would be displayed in that modeling error check. But there are two other options in here for three free edges and four or more free edges. But the standard one that we'll do is just the standard free edge check and then have it check for modeling errors. Under the plate view option, there are options to display the element normals, the element pressure side, and the stiffener side. The stiffener side can be very useful if you're using those orthotropic plates with the embedded stiffener layout for purposes of, specifically like if you had tank pressures, you may want to set the stiffener side appropriately. So whether the stiffeners are on the inside of the tank or outside of the tank, but also if you convert a model that has those embedded stiffeners to become a level 2 model where it converts all of those internal stiffener layouts to actual beams, and it breaks up an initial quad with the embedded stiffeners into multiple quads with discrete beam elements. Based on whatever is defined as the stiffener side, that's the side it's going to put those beams on. So if you're going to convert the model, it would be important to know which side the stiffeners are going to be created on. The other thing is, for the element pressure side, obviously, when you view your wetted elements, you want to make sure that the pressure side on all of those wetted elements is on the exterior surface of the hull. For a quad that's expected to be dry the whole time, pressure side really doesn't matter much. But certainly for any of your wetted elements, you want to make sure that this magenta side is on the outside of the hull. The magenta side is the one that receives the pressure. For plate thickness, there's a number of different options to get this graphical display. You can have it display the thickness of the plate, the thickness of the beam flange or the beam web, as well as, I guess, if you're using composites, you can have multiple layers in the material, or you can have it display a corrosion thickness. And for the corrosion display, we'd have to check whether or not that is the amount of corrosion or the resulting net thickness. If there is a corrosion in the load condition, I think that the net thickness may just be displayed in the plate, but I'm not positive. That's something I'd have to check on. For parent, child, and all modules, these are both used in the fine mesh models. And actually, we can take a quick detour here and switch the model to the tanker model, which is available in the full ship samples here. If we bring up the 44 tanker, and I'm not going to save these models, and keep the original installed ones as they are, you can see this model has a fine mesh model contained in it. Now, where that is, we can't see with the view part. If we switch the view part to the fine mesh model, we get an idea of where that might be on the hull, but we can't see both at the same time. In order to see both at the same time, we'll use view all modules. and that displays everything. You'll see that there's no longer a view part displayed in the tree because it's displaying everything. Essentially, it's displaying the full parts tree when you say all modules. And you can see where that fine mesh model exists in the hull. And you can see in red, these are the rigid splines that act as the connection between the fine mesh model and the coarse mesh model. And the other option that it showed there was dependent independent. So it takes those rigid splines and it shows in magenta which are the independent nodes, and then in yellow the dependent nodes with the fine mesh. So it uses those primary nodes to interpolate data for these edges on the fine mesh. And then to get back, we can simply set a view part for one or the other. And we can turn off the display of those independent dependent nodes. Element x-axis and then you can select either the global X, Y, or Z axis. It basically shows a color map of the angle between the element x-axis and the global x-axis, or the element x-axis and Y or Z. As an example, on this tanker model, if we say between the element x-axis and the global x-axis, set a threshold, we'll just leave it at the default of 0. So it's showing everything from 0 degrees up to 90 degrees in a color mapped fashion. Now our x-axis, you can see, is just the longitudinal axis. If we go into dynamic query, one of the things you need to know is that when you query an element, there's an arrow that is displayed. And for a quad element, and this applies to a tri element as well, it's essentially telling you the order of the nodes defining that quad. The beginning of the edge with the arrow is node 1, and then node 2, node 3, node 4. So this one runs clockwise, starting at the upper left there. And the x-axis is defined by that first edge. So you can see the x-axis of this element is in the same direction as the x-axis, the global x-axis. So we have an angle of 0 on that. If we look at the direction of some of these on the vertical bulkhead, obviously they're going to be 90 degrees regardless of which direction it's pointed, since it's orthogonal. Although if we were to compare the element x-axis to the y-axis, which is vertical in Maestro, x is longitudinal, y is vertical, and z is transverse. So that's one thing you'll need to get a little used to. But if we compare to vertical, you'd see some would be 0, some would be 180. If we look at some of these tries, the first edge of this tri, you can see, starts back aft and goes off at about a 45-degree angle. And if we look at the color bar, green is 45. This tri here, and in red, we can see the first edge is going down. So the X direction on that tri is vertical, and again, 90 degree. The options dialog here is the same thing as the button that we saw. It just brings up the view options dialog, and refresh just as a refresh of the graphics. Sometimes if you have things hidden, like under the view menu here, there's an option to hide elements. So, and I have full strakes checked here. So if I start clicking on some of these strakes, it hides them, and I can see inside the model a little easier. Now, if I close this dialog, it doesn't automatically redisplay all of them. You saw one of them reappear, but the others didn't. Now, they're still in the model, they just haven't redisplayed. Now, if I hit refresh, it brings them back.